Hey, so it's just going to be a couple problems, probably just two of them, from your solution stoichiometry notes. This is probably around page 10. We're doing letter E there. So this is a limiting reactant question with solutions. So aqueous solution, strontium hydroxide, chromium nitrate are mixed. So here's your reaction. This is just the net. So the chromium ions plus the hydroxide ions make a precipitate of chromium hydroxide. So it's not the full equation. You could always write the full equation. It is easier with the full equation, I will tell you that. Okay, you can always write that full equation, which will change the balancing a little bit in terms of how you do it. So I will show this with just the net to start with here. So we want to know the mass of the precipitate form. So we're trying to figure out how many grams of this. That's our goal, for how many grams of that are made. And it tells us we have 45 milliliters of 0.2 molar strontium hydroxide, 40 milliliters, 0.2 molar strontium hydroxide, which makes the hydroxide ions that are involved in the precipitate being formed, and 100 milliliters of 0.15 molar chromium nitrate, which provides the chromium ions in your net ionic equation. So first thing I do is figure out limiting reactant. So I need to know moles of chromium ions and moles of hydroxide ions, not moles of this compound and moles of this compound. I need to know moles of each individual ion in there. So I have molarity and I have milliliters. You can always multiply molarity times milliliters or times liters gives you moles. So for this, I'm going to say I have 0.1 liter. Every liter is 0.15 moles of chromium nitrate. That's just our molarity. Well, each mole of this compound contains 1 mole of chromium ions. Each mole of this compound contains 1 mole of chromium ions, so that is also the molarity of our chromium ions. So 0.1 times 0.15 is going to be 0.015 moles of chromium ions. If it was nitrate ions, it'd be double that, because there's 2 moles of nitrate ions for every mole of that compound. Again, over here, I want to know moles of hydroxide ions because that's what's part of my net ionic equation. So I have 0.045 liters, that's 45 milliliters. Every liter contains 0.2 moles, that's my molarity, using that molarity like that. So remember, you're always writing it as moles per liter. So remember, that is moles of strontium hydroxide. That is not moles of hydroxide. Every mole of strontium hydroxide that dissolves contains 2 moles of hydroxide ions as it dissociates. So I had to get to moles of hydroxide ions because that's what's part of my equation. Now, if you were doing the full equation, you would have the ratio of these. You could use just the molarity of the compound. In this case, we have to know molarity of the ions to figure out our limiting reactant. So this gets to moles of the compound, multiplying those, times 2 because there's 2 moles of hydroxide for every mole of that compound. We do that, that is 0.018, I believe. Should I have that on here somewhere? Yes, it's 0.018 moles. So I'm going to erase this. This is 0.018 moles of OH negative ions. Well, pretty easy to tell my limiting. It's supposed to be a 1 to 3 ratio. That's supposed to be 3 times bigger than that. It's not even double. So way less I need. So this is my limiting reactant. There's excess of this, so I don't want to do anything with that. It's not asking any excess in this case. It just wants to know how many grams of that can be made. So now I can do my stoichiometry, starting with this. And I can just say every 3 moles of hydroxide ions, there's 1 mole of chromium hydroxide that is made. Every 3 moles of these that are used, I make 1 mole of that. That was our mole ratio from our equation. And then a mole of chromium hydroxide is however many grams. In this case, 103 grams is a mole. So multiply, cross, divide. It is 0.618 grams is all you could make from that. Not very many moles though, 0.018 moles is a pretty small number of moles. So again, you could have used the whole equation. Let me just show you real quick here what I mean by that. Okay, because people will ask. So I'm still trying to find grams of that. So if I wrote my whole equation, I'd have chromium nitrate plus strontium hydroxide forms precipitate of chromium hydroxide plus strontium nitrate. So now if we balance that out, we would have to put a 3 in front of this to get 6 hydroxides, a 2 in front of that to get 6 hydroxides there. That gives us 2 chromiums and 3 strontiums. So now there's our balanced equation that way. So knowing that this is my limiting, so we've already figured out this is my limiting here. If we turn this into moles, so 0.045 liters, every liter is 0.2 moles of strontium hydroxide. If we do this, just so you know, that's 0.09 moles of that compound. This is still what it was before, 0.015 moles. Sorry, this is 0.009 moles of IU. Well, this is supposed to be bigger than that. It's not bigger than that, so that's how I know it's my limiting, just like it was before. So if we're doing my stoichiometry, start with that, get into moles, which we just did there. Do my mole ratio. It's a 3-to-2 ratio, 3-to-2. Every 3 strontium hydroxides, there's 2 chromium hydroxides. And then a mole of chromium hydroxide is those 103 grams again. So you could do it either way. I tend to use whatever they give us, okay, as we're doing things. All right, I'm gonna do one more question on this. This one, you have 400 milliliters of 0.75 molar HCl to neutralize with 525 milliliters of 0.65 molar strontium hydroxide. Determine the limiting reactant and the number of milliliters of the excess remaining after the reaction. Sorry, I got cut off here. So what's the limiting? What's the excess remaining? First thing we need is a little equation here, so let's write an equation. So we have HCl plus strontium hydroxide. You could do the net if you wanted to. Makes water plus strontium chloride. If we balance that, we just need a, what we got here? We have to go a 2 in front of our water, is that right? And a 2 in front of our HCl. Gives us 4 hydrogens, 2 oxygens, 2 oxygens, 2 chlorines. All right, we're good there. So we have 400 milliliters, 0.75 molar HCl. So I'm going to make that 0.4 liters, 0.75 molar. Remember, whenever you multiply liters times molarity, it gives you moles. Liters times molarity gives you moles. So if we multiply those, that will give us moles, which is going to be 0.3 moles, I believe. So 0.3 moles of HCl. Strontium hydroxide, we have 0.575 liters, and it's 0.65 molar. So remember, liters times molarity will always give us moles. Get used to that. You can do that a lot of times. That I don't know off the top of my head. That would be 0.374 moles of strontium hydroxide. Well, it's a 2-to-1 ratio. This is supposed to be double that. It's not even more. It's less than this. That's my limiting reactant then. So by far limiting. So we're going to use all of that. This is my excess. And the question asks us, how many milliliters of excess? How many milliliters of excess? So how many of these 525 milliliters are used? How many are left over? So let's figure out how many of those are used. So I'm going to ignore this information, start with my 0.3 moles here. We know we're using 0.3 moles of HCl because it's my limiting reactant. My ratio is 2 moles of HCl for every 1 mole of strontium hydroxide. And then I can use my molarity. I know that for every 0.65 moles of strontium hydroxide, there's 1,000 milliliters of solution. That's just the molarity flipped around. 0.65 moles per liter, 0.65 moles per liter per 1,000 milliliters. So there's this many moles of strontium hydroxide in 1,000 milliliters of that solution, because that's how concentrated it is. So I do that, that would tell me how many milliliters I would use of strontium hydroxide, which is 230.8. So I get 230.8 milliliters of strontium hydroxide. Remember, that is the amount used. Stoichiometry always tells you how much you have used or produced, not the excess. Well, we had 575 milliliters. There were 575 milliliters available. We used 230 because that's all we needed to react off all these moles of HCl. Subtract those, that will tell us our excess. So 344.2. That's our excess, 344.2 milliliters of excess that was not used. Remember, whenever you're trying to get your excess, start with your limiting, go back to your thing that's in excess, figure out how much was used. All right, it's a long video for just 2 problems.